Hello students, in this video we will solve exercise 3.3 of NCERT. Now let us start with the introduction to the exercise. Now the angles from 0 to 2 pi can be divided into 4 quadrants. Now first quadrant includes the angles between 0 to pi by 2. In second quadrant, the angles between pi by 2 and pi will come. Now third quadrant includes the angle between pi to 3 pi by 2, and fourth quadrant includes the angle between 3 pi by 2 to 2 pi. Now in first quadrant all trigonometric functions are positive. In second quadrant, sine and reciprocal of sine, that is cosec, is positive and other trigonometric functions are negative. In third quadrant, tan and reciprocal of tan, that is cot, is positive and other trigonometric functions are negative. And in fourth quadrant, cos and reciprocal of cos, that is sec, is positive and other trigonometric functions are negative. Now sine minus x. Now sine minus x, as we see here, minus x can be taken as 0 minus x, and minus x comes in quadrant fourth. As we know, cos and sec are positive in quadrant 4. So cos minus x will be equal to cos x and sec minus x will be equal to sec x. But other trigonometric ratios of functions are negative in the fourth quadrant. So sine minus x will be equal to sine a minus sine x, tan minus x will be equal to minus tan x, cot minus x will be equal to minus cot x, and cosec minus x will be equal to minus cosec x. Now for the angles pi by 2 plus minus theta or 3 pi by 2 plus minus theta, we will change the trigonometric functions. Now sine will be changed into cos, cos will be changed into sine, tan will be cot, cot will be tan, sec will change into cosec, and cosec will be changed into sec. Now sine pi by 2 minus x. Now pi by 2 minus x. Pi by 2 minus x will come in first quadrant, and in first quadrant all trigonometric functions are positive. So here sine pi by 2 minus x will be equal to cos x, cos pi by 2 minus x will be equal to sin x, tan pi by 2 minus x will be equal to cot x, cot pi by 2 minus x will be equal to tan x, sec pi by 2 minus x will be equal to cosec x, and cosec pi by 2 minus x will be equal to sec x. Similarly, for the angle pi by 2 plus x, now for the angle pi by 2 plus x, angle pi by 2 plus x will come in the quadrant second, and in second quadrant sine and cosec are positive and the other trigonometric ratios are negative. So here sine will become cos x. Cos x will be equal to minus sin x, as cos x is negative in the second quadrant. Tan is also negative in the second quadrant. So tan pi by 2 plus x will become cot x. Now here pi minus x will come in quadrant second. So sin pi minus x will be equal to sin x, as sin is positive at quadrant second. Cos pi minus x will be equal to minus cos x, as cos is negative in second quadrant, and tan pi minus x will be equal to minus tan x, as tan is negative in quadrant second. Now sin pi plus x will come in third quadrant, and in third quadrant tan and cot are positive. So tan pi plus x will be equal to cot x, cos pi plus x will be minus cos x, and sin pi plus x will be equal to minus sin x. Now for the angle 3 pi by 2 minus x and 3 pi by 2 plus x, the trigonometric functions will change, and 3 pi by 2 minus x will come in quadrant third, and in quadrant third tan and cot are positive. So tan 3 pi by 2 minus x will be equal to cot x. But sine and cos are negative in the third quadrant. So sine 3 pi by 2 minus x will be equal to minus cos x. Cos 3 pi by 2 minus x will be equal to minus sin x. Similarly, the angle 3 pi by 2 plus x comes in quadrant fourth, and in quadrant fourth cos is positive. So cos 3 pi by 2 plus x will be equal to sin x. Sin 3 pi by 2 plus x will be equal to minus cos x. As cos and sec are positive in the third quadrant, in the fourth quadrant, so cos 3 pi by 2 plus x will be equal to sin x, and sec 3 pi by 2 plus x will be equal to cosec x, and other trigonometric functions will be negative. Now this tan 3 pi by 2 plus x will be equal to minus cot x, as tan is negative in the fourth quadrant. Now sin 2 pi minus x will again, 2 pi minus x will come in quadrant fourth. 2 pi minus x will come in quadrant fourth. So we can say, and in quadrant fourth cos is positive, sin is negative. So we can say that sin 2 pi minus x will be equal to minus sin x, and cos 2 pi minus x will be equal to cos x, as cos is positive in the quadrant fourth. Now there are other trigonometric identities which we must keep in mind before solving the exercise 3.3. Now here are few of them. Now cos x plus y is equal to cos x cos y minus sin x sin y. Cos x minus y is equal to cos x cos y plus sin x sin y. Sin x plus y is always equal to sin x cos y plus cos x sin y, and sin x minus y is equal to sin x cos y minus cos x sin y. Now third one is tan x plus y is equal to tan x plus tan y upon 1 minus tan x tan y. Similarly, tan x minus y will be equal to tan x minus tan y upon 1 plus tan x tan y. Now cot x plus y will be equal to cot x cot y minus 1 upon cot y plus cot x, and cot x minus y will be equal to cot x cot y plus 1 upon cot y minus cot x. Now cos 2x is equal to cos square x minus sin square x, or if we change, as we know, sin square x plus cos square x is equal to 1. So if we change cos square x into sin, so cos square x can be written as 1 minus sin square x. So cos 2x will be 1 minus sin square x minus sin square x, and this will be equal to 1 minus 2 sin square x. So cos 2x can also be written as 1 minus 2 sin square x, and if we convert sin square x into cos, then cos 2x will be cos square x minus 1 minus cos square x, and that will be equal to 2 cos square x minus 1. So cos 2x can also be written as 2 cos square x minus 1, and cos 2x is also equal to 1 minus tan square x upon 1 plus tan square x. Now sin 2x is equal to 2 sin x cos x, or it can be written in the form of tan x as 2 tan x upon 1 plus tan square x. Similarly, tan 2x will be equal to 2 tan x upon 1 minus tan square x. Now, fifth one, sin 3x is equal to 3 sin x minus 4 sin cube x. Cos 3x is equal to 4 cos cube x minus 3 cos x, and tan 3x is equal to 3 tan x minus tan cube x upon 1 minus 3 tan square x. Now, cos x plus cos y can be written as 2 cos x plus y upon 2 cos x minus y upon 2. Similarly, cos x minus cos y can be written as minus 2 sin x plus y upon 2 to sin x minus y upon 2. Sin x plus sin y is equal to 2 sin x plus y upon 2 into cos x minus y upon 2, and sin x minus sin y is equal to 2 cos x plus y upon 2 sin x minus y upon 2. Now, seventh identity, 2 cos x cos y is equal to cos x plus y plus cos x minus y minus 2 sin xy will be equal to cos x plus y minus cos x minus y. 2 sin x cos y will be equal to sin x plus y plus sin x minus y, and 2 cos x sin y will be equal to sin x plus y minus sin x minus y. Now come to exercise 3.3. In question number 2, we have to prove 2 sin square pi by 6 plus cosec square 7 pi by 6 into cos square pi by 3 equal to 3 by 2. Now first of all, we will take the left hand side of the question, that was 2 sin square pi by 6 plus cosec square 7 pi by 6 into cos square pi by 3. Now pi by 6 and pi by 3 are between 0 to 2 pi. Now 7 pi by 6 is greater than 2 pi. So cosec 7 pi by 6 can be written as cosec square pi plus pi by 6. Now here pi plus pi by 6 lies in the third quadrant, and as we know that cosec is negative in third quadrant, so cosec pi plus pi by 6 will be equal to minus cosec pi by 6, and here square of cosec will be equal to plus cosec square pi by 6, as square cannot be negative. So cosec square pi plus pi by 6 can be written as cosec square pi by 6. As we know, value of sin pi by 6 is 1 by 2. So sin square pi by 6 will be square of 1 by 2. And cosec pi by 6 is equal to 2. So cosec square pi by 6 will be equal to square of 2. Cos pi by 3 is equal to 1 by 2. So cos square pi by 3 will be equal to 1 by 2 whole square. Now this on solving will give us the value as 3 by 2, which is equal to the right hand side. Now in first part of question number 5, we have to find the value of sin 75. Now sin 75 can be written as sin 45 plus 30. Now formula for sin x plus y is equal to, now sin x plus y is equal to sin x cos y plus cos x sin y. So sin 45 plus 30 will be equal to sin 45 cos 30 plus cos 45 cos 30. Now value of sin 45 is 1 by root 2. Cos 30 is equal to under root 3 by 2. Cos 45 is equal to 1 by root 2, and sin 30 is 1 by 2. Now this on solving will give us the value of sin 75 as root 3 plus 1 upon 2 root 2, which on rationalizing will be equal to root 6 plus root 2 upon 4. Now in second part of question number 5, tan 15 can be written as tan 45 minus 30, as we know that tan x minus y is equal to tan x minus tan y upon 1 minus tan x tan y. So 1045 minus 30 can be written as 1045 minus 1030 upon 1 plus 1045 1030. Now we can put the values of 1045 and 1030 to find out the value of 1015, which is coming out to be 2 minus root 3. In question number 6, we have to prove cos pi by 4 minus x into cos pi by 4 minus y minus sin pi by 4 minus x into sin pi by 4 minus y is equal to sin x plus y. Now, as we see here, this question on taking this left hand side is in the form of cos x cos y minus sin x sin y. And as we know that cos x plus y is equal to cos x cos y minus sin x sin y. So we can say that this can be written as cos x plus y. Now here in place of x there is pi by 4 minus x, and in place of y there is pi by 4 minus y. So it can be written as cos pi by 4 minus x plus pi by 4 minus y, which on solving will give us cos pi by 2 minus x minus y. Now on taking minuses common, this will be equal to cos pi by 2 minus x plus y. Now cos pi by 2 minus theta. Cos pi by 2 minus theta this pi by 2 minus theta will be in first quadrant, and as we know that cos is positive in the first quadrant, so it will be equal to sin theta. So cos pi by 2 minus x plus y can be written as sin x plus y. And question number 7, we have to prove 10 pi by 4 plus x upon 10 pi by 4 minus x is equal to 1 minus 10x upon 1 minus 1 plus 10x upon 1 minus 10x whole square. Now taking left hand side. Now left hand side of the question was 10 pi plus 4 pi by 4 plus x upon 10 pi by 4 minus x. As we know, 10x plus y is equal to 10x plus 10y upon 1 minus 10x 10y. So 10 pi by 4 plus x can be written as 10 pi by 4 plus 10x upon 1 minus 10 pi by 4 10x. Now 10x minus y is equal to 10x minus 10y upon 1 plus 10x 10y. So 10 pi by 4 minus x can be written as 10 pi by 4 minus 10x upon 1 plus 10 pi by 4 10x. Now on putting the value of 10 pi by 4, which is equal to 1, so this will be 1 plus 10x upon 1 minus 10x. Now 1 into 10x will be equal to 10x upon 1 minus 10x upon 1 plus 10x, which gives us the answer as 1 plus 10x upon 1 minus 10x whole square, which was equal to right hand side. In question number 8, we have to prove cos pi plus x into cos minus x upon sin pi minus x into cos pi by 2 plus x is equal to cot square x. Now on taking left hand side, which was cos pi plus x into cos minus x upon sin pi minus x into cos pi by 2 plus x. Now cos pi plus x, now pi plus x lies in the third quadrant and cos is negative in the third quadrant. So cos pi plus x will be equal to minus cos x. Cos minus x lies in fourth quadrant, and fourth quadrant minus x. Yeah, you can say cos is positive. So cos minus x will be equal to cos x. Similarly, sin pi minus x lies in second quadrant. Pi minus x lies in second quadrant and sin is positive in second quadrant. So sin pi minus x will be equal to sin x. Cos pi by 2 plus x lies in second quadrant and pi cos is negative in second quadrant. So cos pi by 2 plus x will be equal to minus sin x. This will give us minus cos square x upon minus sin square x, which is equal to cot square x, as cos upon sin is equal to cot, and this was our right hand side. In question number 9, we have to prove cos 3 pi by 2 plus x into cos 2 pi plus x into cot 3 pi by 2 minus x plus cot 2 pi plus x is equal to 1. Now on taking the left hand side of the question, cos 3 pi by 2 plus x lies in this 3 pi by 2 plus x lies in fourth quadrant, and cos is positive in fourth quadrant. So cos 3 pi by 2 plus x, and also trigonometric function changes for 3 pi by 2 plus minus x. So cos 3 pi by 2 plus x will be equal to sin x. Now cos 2 pi plus x will come in the first quadrant. Now this one is 2 pi, and 2 pi plus x will be in first quadrant. And in first quadrant, all the trigonometric functions are positive. So cos 2 pi plus x will be equal to cos x. Again here, cot 3 pi by 2 minus x. 3 pi by 2 minus x lies in third quadrant, and third quadrant cot is positive. So it will be equal to 10x. Cot 2 pi plus x will again lie in the 2 pi plus x will lie in the first quadrant. First quadrant, all the trigonometric functions are positive. So cot 2 pi plus x will be equal to cot x. Now on writing this 10x and cot x in forms of sin and cos, 10x can be written as sin x upon cos x, cot x can be written as cos x upon sin x, which on taking LCM will give us sin square x plus cos square x upon sin x cos x. Now sin x cos x will cancel out with sin x cos x, and as we know, sin square x plus cos square x is equal to 1, which was our right hand side. Now in question number 10, we have to prove sin n plus 1 x into sin n plus 2 x plus cos n plus 1 x into cos n plus 2 x is equal to cos x. Now, as you know that cos x minus y is equal to cos x cos y plus sin x sin y, and here the left hand side is in the form of cos x cos y plus sin x sin y. So it can be written as cos x minus y. Here in place of x there is n plus 1 x, in place of y there is n plus 2 x, and this on solving will give us the answer equal to cos minus x. Now cos minus x will lie, this minus x will lie in the fourth quadrant, and fourth quadrant cos is positive, so cos minus x will be equal to cos x, which was our right hand side. In question number 11, we have to prove cos 3 pi by 4 plus x minus cos 3 pi by 4 minus x is equal to minus root 2 sin x. Now here left hand side is in the form of cos x minus cos y. As we know, the formula for cos x minus cos y is equal to minus 2 sin x plus y upon 2. Here cos x minus cos y is equal to minus 2 sin x plus y upon 2 into sin x minus y upon 2. So cos 3 pi by 4 plus x minus cos 3 pi by 4 minus x can be written as minus 2 sin 3 pi by 4 plus x plus 3 pi by 4 minus x upon 2 sin 3 pi by 4 plus x minus 3 pi by 4 minus x upon 2. Now, which on solving will give us minus 2 sin 6 pi by 4 by 2 into sin 2x by 2. Now here 2 will cancel out, and this will be equal to minus 2 sin 6 pi by 8 into sin x, which will be equal to minus 2 sine 3 pi by 4 into sine x. Now sine 3 pi by 4 can be written as pi minus pi by 4. Now as we know, this angle pi minus pi by 4 will lie in, here it will be pi. So pi minus pi by 4 will lie in the quadrant second. And in second quadrant sine is positive. So sine pi minus pi by 4 will be equal to sine pi by 4. Now value of sine pi by 4 is 1 by root 2. So this will be equal to minus 2 into 1 by root 2 into sine x. Now root 2 upon root 2 will be equal to root 2, and this will be equal to minus root 2 sine x, which was our right hand side. In question number 13, we have to prove cos square 2x minus cos square 6x equal to sine 4x sine 8x. Now here our left hand side was cos square 2x minus cos square 6x. Now cos square 2x can be written as 1 minus sine square 2x, and cos square 6x can be written as 1 minus sine square 6x. And that will be equal to 1 minus sine square 2x minus 1 plus sine square 6x, which will be equal to sine square 6x minus sine square 2x. Now sine square 6x minus sine square 2x can be written as sine 6x minus 2x into sine 6x plus 2x by identity sine square x minus sine square y is equal to sine x minus y into sine x plus y, which will be equal to sine 4x into sine 8x, and that was our right hand side. Now question number 13 can be solved. Question number 12 can be solved by using the same identity sine square x minus sine square y equal to sine x minus y into sine x plus y. In 14th question, we have to prove sine 2x minus 2 sine 4x plus sine 6x equal to 4 cos square x into sine 4x. Now left hand side was sine 2x plus 2 sine 4x plus sine 6x. On taking sine 2x and sine 6x together, we can write this as 2 sine 4x plus sine 2x plus sine 6x. As we know, sine x plus sine y is equal to 2 sine x plus y upon 2 into cos x minus y upon 2. So sine 2x plus sine 6x will be equal to 2 sine 2x plus 6x upon 2 into cos 2x minus 6x upon 2. Now that will be equal to 2 sine 4x plus 2 sine 2x plus 6x upon 2, that will be equal to 4x cos minus 2x. Now on taking 2 sine 4x common, we are getting 2 sine 4x into 1 plus cos minus 2x, as minus 2x lies in fourth quadrant. So cos is positive in fourth quadrant. So cos minus 2x will be equal to cos 2x. Here the right hand side is in the form of 4 cos square x into sine 4x, and sine 4x is already there, so we will convert cos to x, or we will write cos 2x in terms of cos square x. Now as we know, cos 2x is equal to 2 cos square x minus 1. So here we can write this cos 2x as 2 cos square x minus 1, which on solving will give us 2 sine 4x into 1 plus 2 cos square x minus 1. Hereafter cancelling 1, that will be equal to 2 sine 4x into 2 cos square x, which can be written as 4 cos square x into sine x, and that was our right hand side. In question number 15, we have to prove that cot 4x into sine 5x plus sine 3x is equal to cot x into sin 5x minus sin 3x. Now, our left hand side was cot 4x into sin 5x plus sin 3x. Now, cot 4x can be written as cos 4x upon sin 4x. Now, and sin x plus sin y is equal to 2 sin x plus y upon 2. Now, sin x plus sin y is equal to 2 sin x plus y upon 2 into sin x minus y upon 2. So sin 5x plus sin 3x can be written as 2 sin 5x plus 3x by 2 into sin 5x minus 3x by 2. Now that will be equal to cos 4x upon sin 4x into 2 sin 8x by 2, that will be equal to 4x, and sin 2x by 2, that will be equal to sin x. Now here sin 4x will cancel out with sin 4x to give us the answer as 2 cos 4x into sin x. Now come to the right hand side. Now right hand side was cot x into sin 5x minus sin 3x. As we know, sin x minus sin y is equal to 2 cos x plus y upon 2 into sin x minus y upon 2. So this can be written as cos x upon sin x. Now cot x can be written as cos x upon sin x, and sin 5x minus sin 3x can be written as 2 cos 5x plus 3x upon 2 sin 5x minus 3x upon 2. By identity, sin x minus sin y equal to 2 cos x plus y upon 2 sin x minus y upon 2. And this on solving is giving us the answer as 2 cos 4x into cos x. Now from equation first and second, we can say that our left hand side is equal to the right hand side. In question number 21, we have to prove cos 4x plus cos 3x plus cos 2x upon sin 4x plus sin 3x plus sin 2x is equal to cot 3x. Now, the left hand side can be written as cos 4x plus cos 2x plus cos 3x whole upon sin 4x plus sin 2x upon plus sin 3x. Now, by the identity, cos x plus cos y equal to 2 cos x plus y upon 2 cos x minus y upon 2, and sin x plus sin y is equal to 2 sin x plus y upon 2 cos x minus y upon 2. Cos 4x plus cos 2x can be written as 2 cos 4x plus 2x upon 2 cos 4x minus 2x upon 2, and sin 4x plus sin 2x can be written as 2 sin 4x plus 2x upon 2 cos 4x minus 2x upon 2. And this on solving will be equal to 2 cos 3x cos x plus cos 3x upon 2 sin 3x cos x plus sin 3x. Now in numerator we can take cos 3x as common, and denominator we can take sin 3x as common. So this is giving us cos 3x into 2 cos x plus 1 upon cos 3x into 2 cos x plus 1. Now 2 cos x plus 1 will cancel out to give us cos 3x upon sin 3x, which will be equal to cot 3x, and that was our right hand side. In question number 22, we have to prove that cot x, cot 2x minus cot 2x, cot 3x minus cot 3x into cot x is equal to 1. Now this can be solved by taking cot 3x equal to cot 2x plus x. Now cot x plus y is equal to cot y, cot x minus 1 upon cot y plus cot x. So cot 2x plus x will be equal to cot x cot 2x minus 1 upon cot 2x plus cot x. which on cross multiplication with cot 3x will give us cot 2x into cot 3x plus cot 3x into cot x equal to cot 2x minus 1, which will be equal to cot 2x minus cot 2x cot 3x minus cot 3x cot x equal to 1, which we have to prove. Now in question number 23, we have to prove that tan 4x is equal to 4 tan x into 1 minus tan square x upon 1 minus 6 tan square x plus 10 to the power 4x. Now on taking left hand side, tan 4x can be written as tan 2 into 2x. Now tan 2x equal to 2 tan x upon 1 minus tan square x. So tan 2 into 2x will be equal to 2 tan 2x upon 1 minus tan square 2x. Now again this tan 2x can be written as 2 tan x upon 1 minus tan square x, and in denominator also tan 2x can be written as 2 tan x upon tan square x, which on solving will be equal to 4 tan x upon 1 minus tan square x upon 1 minus 4 tan square x upon 1 minus tan square x whole square. Now on taking 1 minus tan square x whole square LCM in the denominator, we are getting 4 tan x upon 1 minus tan square x whole upon 1 minus tan square x whole square minus 4 tan square x upon 1 minus tan square x whole square, which will be equal to 4 tan x upon 1 minus tan square x into 1 minus tan square x whole square upon 1 minus tan square x whole square, which will be equal to 1 minus 2 tan square x plus 10 to the power 4x minus 4 tan square x. And here 1 minus tan square x will cancel out with 1 minus tan square x to give us 4 tan x into 1 minus tan square x upon 1 minus 2 tan square x. Now 2 tan square x minus 4 tan square x will be equal to minus 6 tan square x plus 10 to the power 4x, which was our right hand side. Now in question number 24, we have to prove cos 4x equal to 1 minus 8 sin square x cos square x. Now cos 4x can be written as cos 2 into 2x. As we know, cos 2x is equal to 1 minus 2 sin square x. So cos 2 into 2x can be written as 1 minus 2 sin square 2x. Again, sin 2x is equal to 2 sin x cos x. So here sin 2x can be written as 2 sin x cos x, and sin square 2x can be written as 2 sin x cos x whole square. Now which on solving will give us 1 minus 2 4 sin square x cos square x, and that will be equal to 1 minus 8 sin square x cos square x, which was our right hand side. Now in last question of the exercise, we have to prove cos 6x equal to 32 cos x raised to power 6 minus 48 cos x whole raised to power 4 plus 18 cos square x minus 1. Now on taking left hand side, cos 6x can be written as cos 2 into 3x. As we know that cos 2x equal to 2 cos square x minus 1. So cos 2 into 3x can be written as 2 cos square 3x minus 1. Now again, cos 3x is equal to 4 cos cube x minus 3 cos x. So here cos square 3x can be written as 4 cos cube x minus 3 cos x whole square. Now this will be equal to 2 into 16 cos to the power 6x plus 9 cos square x minus 24 cos to the power 4x, minus 1. Now this one solving will be equal to 32 cos to the power 6x minus 48 cos to the power 4x plus 18 cos square x minus 1, which was our right hand side. Thank you.